Mapping quantity itself is not the end of the purpose. We must have a step that can say something about the pattern. So the question is, what can we say about any of those quantity-based patterns? Here we're going to talk about a few guidelines. We may interpret the maps of quantitative values or attributes from a number of angles. First, we could look at the high or lows of value, which should be obvious from the graduate color or graduate symbol. We also can look at where those highs and lows are located. Are they going to form some kind of close by clusters? That means the high values tend to occur in the vicinity of other high values. Some other cases we can look at whether the high value and low value have very sharp boundaries or very smooth transition across those areas with highs and lows. Okay. Other cases we may want to look at whether the highs and lows are representing certain kind of trends. The trend could be temporal but also could be spatial. For example, you may see a trend from northeast to southwest where there are certain patterns going on. You may also see that there's a correlation between the highs and lows on one phenomenon to the highs and lows of another phenomenon. For example, you may see that economic activity or retail shops may be highly correlated with certain kind of crimes, and those are the things you want to look for. One potential trap of interpreting map patterns in the quantified data classes is that some of the numerical values could be sensitive to the size of the area. For example, you may want to map the poverty rate of the area by either census block or census tracts. Depending on which area unit you want to use, you may find there's very different patterns of poverty. On the map on the left, you see there's a more serious poverty, but the map on the right seem relatively less. But they are actually from the same baseline data. So the reason is that the area unit you use for summarizing those numbers may bring up very different pattern. So this is the trap, and sometimes we take for granted that larger value will be corresponding to worse problem. But if the large value corresponds to also to a large area, they may not show that pattern as we want to pick up. So in many cases, we want to use other methods to correct it. For example, we could map by density, by ratio, and those will be less sensitive to the size of the area. In mapping quantities from place to place, we should try to avoid making conclusions very quickly only based on one map or two maps. Um, because understanding a place is a very complex issue. We should try to use as many attributes as we can to triangulate our understanding, to cross compare the patterns and resolve any conflicts of the data. For example, in order to understand the population distribution, we could look at a series of maps. We can look at total population, we can look at the population of Native America. We also can look at the absolute number of population and compare to the density map of the population. So by putting a series of map, or we call it atlas of maps, we could derive a much better solution or conclusion.